So working with more transformations of functions, looking at different types and labels for functions, we have even functions. Graphically, what we would look for is if there's a xy, there's another point that if I plug in negative x, I also get a y. So two x values give you the same y value. Algebraically, you take the function, you plug in negative x for all the x's, and when you simplify, you get the original function back out. An odd function, well, neither, it doesn't fit either of the above. Odd, if xy is on the graph, then negative x, negative y. That means if I have something in the first quadrant, I have something mirror image in the third quadrant. What that looks like graphically is if you spin about the origin, well, what that looks, graphically as you spin about the origin, it matches. For algebraically, you plug in negative x for all the x's, and you get the function that is negative of the original. That means if you take negative 1 times all the terms, you get the original function. Now we've got an example down at the bottom. We got 3 of them. So we take a look at A, and so it's graphically. So I'm looking, again, even is y-axis line of symmetry. So if I fold along the y-axis, is the left going to match the right? No. So that doesn't match, so it's not even. If I spin about the origin, is it going to line up? No. So this is neither. Okay. On B, can I fold across the y-axis and it match up? Yep. So this is even. Now C, it's the function without the graph, so I have to do it algebraically. So we plug in negative x for all the x's, and we get negative x to the 5th power is going to be negative x to the 5th power. Negative x to the 3rd turns that into negative 2 times negative x to the 3rd, so that gets us plus 2x to the 3rd. And then the last is just minus 4x. So if I pull out a negative 1 from everybody, I get the original. So this is negative 1 times the original function. That makes it odd. Now go ahead and practice it on your own and pause the video. And when you're done, move on to the next piece. Next piece, example 2. An employee at a garden center fills a water tank once a day around noon to a height of 6 inches. The function m models the height of the water in the tank, m of x in inches, x seconds after 12 p.m. on Monday as it fills. Here's the equation and graph of m below. M of x is equal to 2 square root of x. The function w gives the height of the water in the tank, w of x in inches, x seconds after 12 p.m. on Wednesday as it fills. Here's the equation and graph of w. W of x equals 2 times the square root of 3x. Describe how the tank filling on Wednesday was like Monday and how it was different than Monday. So taking a look, it still fills to the same height. The difference is it looks like it takes a lot less time. Instead of taking 9 seconds, it takes 3 seconds. So that took a total of 9 seconds. That takes a total of 3 seconds. So it's a third of the horizontal distance. So it looks like it shrunk horizontally by a third. It takes 3 seconds instead of 9 seconds to fill. So on Wednesday, it's filling 3 times as fast. And that really comes from that 3 inside with the x. That's like B. So on Friday, the employee starts filling the tank 2 seconds after 12 p.m. The function f models the height of the water in the tank, f of x in inches, x seconds after 12 p.m. as it fills. Sketch a graph and write an algebraic equation for f. Well, just about everything's the same, except the graph, we would just take and shift it right 2 units. Okay, that affects the x inside. So there would be what the graph looks like. We just subtract off 2 from the x to move it to the right. And that would just shift the graph to the right, as you see here. If I wanted to take twice as much time, that means starting at 2 going to 11, let's see, that's 9, I'd have to add another 9, so it would go out to 20 seconds to fill the tank. Practice 2, do the same thing, just with different information. So pause the video, and when you're ready, unpause to move on to the last example. And again, there's 2 parts to practice 2. Now, example 3, a juggler throws a ball from hand to hand. The path the ball takes for the upward throw from hand to hand follows a path that is shaped like a parabola. The arc created by the ball is 20 inches wide and 18 inches high. Use the description of the juggler's ball to label the 3 points on the graph modeling the path of the ball. Well, where it starts would be kind of like at 0, 0, and at 20 inches wide, so the other one would be 20, 0. And then the max height is 18 inches high, and that would be halfway between 0 and 20, so that'd be about 10. So there we've got the points. Find a quadratic function j that models the ball height. Well, we start with, we've got the 2 x-intercepts, so we would want to use the factored form. We've got p is 0 and q is 20, so plug those in. And then we take the other point, 10, 18. We plug in 10 for all the x's, and we plug in 18 for j of x. So, and then start simplifying. 10 minus 20 is negative 20, so we get 18 equals a times 10 times negative 10, so that's negative 100a. Divide both sides by negative 100, and we get a is negative 18 over 100. Now we just go back up to that line, j of x equals a times x minus 20, and plug in the negative 0.18. We've got our equation. So minimum for a quadratic, you kind of need 3 points. It really helps to have the 2 x-intercepts and 1 other point. Part C, what if the arc were 20 inches wide but 25 inches high? How could you modify your function j to model the new arc? Explain or show your reasoning. So again, we start, it's still hitting at the same 2 points P and Q. It's just now at 10, it's at 25. So the point we plug in now is 10 and 25. And what that's going to do, we should have a number that's further away from 0 to stretch it vertically. And so plugged in the 10, plugged in the 25, now we start simplifying. Again, that's going to be negative 100 times a equals 25, and that gets us negative 1/4 versus, so negative 0.25 versus negative 0.18, and 0.25, yes, is further from 0. And that gets us our equation. Okay. And now you've got practice on your own, asking you to do similar work. It's just the numbers have changed. And when you finish, submit the checkpoint for feedback.